Radhe Radhe students. So today we are going to start a new chapter, gravitation. Right? Gravitation is a phenomena in which every object in this universe which have some mass attracts other objects. Right? Out of four fundamental forces in this universe, there are four fundamental forces, in which gravitational force is weakest force. Right? So any which have some mass, it attract another object, which obviously would have some mass. So this force between two objects having masses. So a charge exert force on another charge particle, but that force is named electrostatic force. Cause of gravitational force is mass. So if any object having mass is placed somewhere, definitely attract other object nearby it. Okay, so let's start learning this chapter. So gravitation is a force of attraction. It- this is always a attractive type of force, right? It can never be repulsive. So this is also property of gravitational force. It is always attractive in nature. So gravitation is a force of attraction that acts between all those objects which have mass in the universe. They say example, for example, Earth attracts Moon and also Sun because both have masses. Even I attract this laptop, this ceiling fan, because uh, that fan has some mass and I have also two masses attracts each other with a force which is known as gravitational force. It depends on mass of two bodies and distance between them. So between two heavier, this force will be greater in comparison to gravitational force between two lighter objects. Third property is negligible for object of small masses, right? Because we already discussed in second point, this force depends on mass. So heavier the masses, greater will be the effect of this force. So it is negligible between two ordinary objects whose masses are negligible. Next point, fourth, its effect is noticeable in tremendous heavy object. So heavy object, this force will act in greater amount, right? For example, gravitational force between sun and planets and satellite, these are really a greater in magnitude. So Kepler and Newton are two scientists who have contributed much in gravitation, field of gravitation. Newton's universal law of gravitation. Learning this universal law of gravitation. So based on several experiment and observation of Newton, he statement every body is universe attracts every other body which with some force which is directly proportional to the product of their masses. So this force, gravitational force, is directly proportional is directly proportional to product of masses. This is experimental law. From experiment, Newton concluded these points. So this force is directly proportional to product of masses, and it is inversely proportional to square of distance between them. Suppose this is mass m1 and this one is m2. Then force between these two masses means force exerted by m1 on m2 and force exerted by m2 on m1. These forces is directly proportional to product of their masses and inversely proportional to separation between them. If r is distance between them, then this force is going to be inversely proportional to 1 by inversely proportional to r square. And mathematically, we write it f proportional to 1 by r square, right? So this force is directly proportional to product of masses and inversely proportional to distance between masses. So here a proportionality constant is introduced, which is also known as gravitational constant, and its value is fixed throughout the universe. And you know what is its value? Its value is 6.67 into 10 to the power minus 11, and its unit is Newton meter square per kilogram square. This is value of universal. Properties of gravitational force. So as we all know that there is force in nature. There are four kind of forces in nature: weak nuclear force, strong nuclear force, electromagnetic force, and last one is gravitational force. So it is those four forces. It is attractive in nature. Other forces, electromagnetic force, can be attractive or repulsive depending on nature of charges. Like charges repel each other, and unlike charges attract. But gravitational force is always attractive in, right? It is mutual force. Mutual force means if one body apply force on other, then other body will apply also on first. It is central force. What do you mean by central force? Central force is that kind of force which act along joining centers of two objects. Suppose M1 and M2 are two forces, then M1 will exert force on M2 along which is constructed by joining their centers, center to center. Let's join these two lines. Then force by M1 on M2 will be along this line. This line. M1 will not exert force on M2 line or this line. It will exert force on M2 along line joining their centers. That's why it is called also called central force. It is mass and distance dependent. We have already discussed this. Uh, this force is directly proportional to product of the masses. So it is mass and distance dependent. It obeys inverse square law because it is inversely proportional to square of separation between them. So it obeys inverse square law. It's a long range force. That means this force acts between two planets, between a star and planet. So it's a very long range force. But nuclear force, as you all know that we all know, it acts only inside the nucleus, right? But gravitational force acting between star and planet, between two planets. So it's really a long force. So by combining this property, F equal to G M1 square, we can write G equal to FR square upon M1 M2. As we know that F equal to G M1 M2 by R square. So if you cross multiply it, you can easily get this value G equal to FR square upon M1 M2, right? So the value of universal gravitational constant is this one. Capital G and small g are two different things. Small g is acceleration due to gravity, whose value is 9.8 meter per second. Capital G is universal gravitational constant. This capital G varies from one point to another point. Its value is 9.8, and on moon its value is 1/6 of 9.8. But capital G is same everywhere in the. That's why it is called universal gravitational constant, right? So when G will become equal to F, so for G to become equal to F, we have to select M1 and M2 as 1 kg and R as 1 meter. So if we calculate force between two masses having mass 1 kg and placed at a distance of 1 meter, then definitely we will get force F equal to G. That means 6.67 10 to the minus 11 Newton. Right? Next point is gravitational force is weakest. We have already discussed these things and value of G. Right? This thing we have already discussed. The gravitational force due to Earth on an object of mass 1 kg is 9.8 Newton. Means near Earth's surface, if you drop any object of mass 1 kg, then it will be attracted towards the Earth with a force which is equal to mg. That means 1 into 9.8. So we can write it as 9.8 Newton. So So any object having mass 1 kg will be attracted towards the Earth with a force 9.8 Newton. You can also write it approximately 10 Newton. The gravitational force between Earth and Moon, even at a large distance, is very large, which is 2 into 10 to the power 20 Newton. Like here, you can see that this is Earth and this Moon, and they are far away from each. Still, this force is acting, and its value is 2 into 10 to the power 20 Newton. Gravitational force of Earth or gravity. So, for only for Earth, if we talk about gravitational force of Earth, then it is called gravity. Force between Jupiter and Sun is not known as gravity. Gravity is used only for Earth, right? So Earth attracts all objects which is in the field of its gravitation. So the force with which Earth pulls the object towards its center is called gravitational force or gravity. This gravity, right? The gravitational force of the Earth or gravity for holding the atmosphere above the Earth, for rain falling on the Earth, for water in the river, for keeping us firmly on the Earth, for the revolution of moon around the Earth. Okay, tides due to moon and sun gravitational force, right? So now let's start learning tides due to moon and sun gravitational force. So sun attracts uh, water of ocean, right? So ocean water is attracted towards the sun, so towards the moon. So when sun and moon are opposite to each other, then this force is much larger as comparison to other position of sun and moon. Like this position or situation may arise in which moon and sun become 90-degree with earth, means they are forming 90-degree angle with earth. In this situation there will also be a tide. Tide is known as neap tide, right? And when they are opposite to each other, then in this case water level rises up to very high level, right? And water start flowing from higher level to lower level. So in this way water start moving from this side to this side. Okay, so this is called ocean tides, and flow of water current due to ocean tide is known as ocean current, right? Ocean water current. When sun and moon are opposite to each other, in that case tides is known as spring tide, right? Opposite to each other. And when they are at 90-degree to each other, this is known as neap tides, right? So it let's try to discuss this topic. Why moon does not fall on earth directly, right? This thing we will discuss here. Students, if you throw any object from some height with some speed, then after moving some distance, it will fall on the ground like this. If you throw this object with greater speed, then it will go here and again fall at ground. Certain speed, if you throw it, then its initial velocity will be along this direction, and force, gravitational force, is acting towards the center, right? Continuously acting towards the center of the earth. So it will start moving towards the earth, but before falling on the ground, its will become parallel to this surface, right? And since gravitational force always acting perpendicular to tangential velocity, this velocity, so magnitude of this velocity will not change. this gravitational force will only change direction of falling object. So in this way, for certain velocity, this magnitude of this velocity will remain constant and gravitational force will be utilized to provide only centripetal. So in this figure, second figure, you can see that for certain velocity v, if you throw any object, then it will start falling along this line, and force is acting along center, towards center and along radius. So this force will not change the speed of this moving object. So this object will always try to fall on Earth, but there is no force acting along the velocity. So no force is here to change its velocity. So for same velocity, it will start same speed because since direction is changing, so we can't say that velocity is constant, only speed is constant. So with constant speed, it will start revolving around the Earth and it will fall on the Earth. Why it is not falling? Because force is acting perpendicular to velocity. So this force has no contribution along the velocity or opposite to velocity. So it will not change its velocity. It will change only its direction, not magnitude of velocity. So with same speed, it will continue to be revolving along circular path. This path. Okay. Student, which figure best represent the gravitational force acting on you on the Earth? You can see that gravitational force is acting on you only due to Earth, and you are not attracting Earth. So this is wrong figure. If we talk about figure B, in this figure, this person is attracted towards Earth, and this one is also attracting Earth. Uh, Best representation. C figure is also wrong because why C figure is wrong? Because in figure C, this lady is attracted towards the Earth, and Earth is also attracted downward. So this is not possible. Action reaction forces are in opposite, right? But here both are in along same direction. So this figure is also wrong. And this figure is also wrong because it's that gravitational force is repulsive in nature. This woman is feeling force in upward direction and this earth is feeling a force in downward direction. So it's not possible because gravitational force is always attractive in nature. Let's solve this numerical. The moon, the mass of the earth is 6 into 10 to the power 24 kg and that of moon is this much separated by a distance 3.8410 to the power 3 kilometer. Calculate the force exerted by the earth on the moon. This is very simple question. You just have to use formula F equal to G m1 m2 by r square. And everything is given here. G we already know 6.7 10 to the minus 11 and earth mass of the moon and distance between them. All by putting this value, you will simply get this result 2.01 into 10 to the power 20. Let's try to solve the second numerical. A planet of mass m has two identical moons, each of mass m. Moon 1 is in a circular orbit of radius r. Moon 2 is in circular radius of 2r. What is the ratio of magnitude of gravitational force exerted by the planet on Moon 1 to Moon 2? So basically, we use here formula of force F equal to G m1 m2 by r. So we will use this formula two times. Once for satellite 1, which is GMM by R, and F2, which is the force acting on satellite 2, which is 2R distance from the Earth. So 2R distance we will write here 2R. So simply we have to divide F1 and F2. So by dividing these two terms, G will cancel out, also cancel out. So you will get result 4 is to 1. So forces acting on two satellites are in 4 is to 1. Okay, got it. Next numerical is the gravitational force between two objects is 49 Newton. How much must be the distance between the object be decreased so that the force between them become double? Force को क्या करना है double, तो separation should decreases because is inversely proportional to distance. So to increase amount of force, distance between two objects must decreases. So initially it was at separation r, and let's consider finally it is at a separation of r dash. So we all know that this force f dash should be 2 times of f. So if you divide this, then you will easily get this relation between r dash and r, right? So f upon f dash, so f dash, so this f will cancel out and you will get result 1 by root 2. So what will be the value of r? R dash will be equal to r upon root 2. Is it clear? So this is another numerical. I think this is another numerical. Yes. Question: how does the force of gravitation between two objects changes when the distance between them reduces to half? So since distance is reduces to half, so r dash will be equal to r by 2. And as we all know that f inversely proportional to r, so f is 1 upon r square, and finally f would be equal to 1 upon r1 square. So if you divide these two forces, f1 by f2, which is required in this question, then this uh, r1 and r2. So in place of r1 you write r, and in place of r2 you have to write r by 2. So r square and this is r by 2. So this r square would cancel out and 2 square become 4. So f1 by f2 is 4. So f1 can be written as 4 times of f. So final force acting on this object will become 4 times of initial value of force. Okay, students. So that's all in this lecture. In next lecture, we will start with other part of this chapter, which is Kepler's law. So that's all for today. Radhe Radhe everyone.